Welcome everyone to Novus. So I think some of y'all must be wondering what Novo is. Let me tell you a story. There was a girl who was always interested in ingredient analysis in food products and a cosmetic that she bought. She also wanted her family members to be more aware of their health by making healthier food choices. However, the food labels are far too complicated for the average consumers to understand. And she thought to herself, what could she do to help someone with no knowledge about nutrition understand the food labels and the importance of choosing a safe and healthy product that contains at least harmful substances and more health benefits as possible? So after 3 months learning machine learning at Coder School, she developed Novus with a goal to help other people evaluate and understand the food product, finally make a healthier and cleaner substitution. So what can Novus do? Novus has three main programs. First, it will provide the user with informative nutrition knowledge. Second, it automates the additive detection and quality assessment of packaged foods based on two international grading systems, Nova and Nutri-Score. Lastly, it recommends the user with a substitution for the unhealthy food and that also matches their preference. The quality assessment of Novus has two main grading systems, Nutri-Score and Nova. Nutri-Score indicates the overall nutritional quality of food items based on a five-color logo with corresponding letters from A to E, with A is green to represent the best nutritional quality, while E is red to show the lowest quality. Nutri-Score is calculated by taking into account the bad nutrients such as calories, saturated fat, sugar, and salt, and those good nutrients such as fiber, proteins per 100 grams of food. For example, whole grain rolled oats will have points between -15 and -1, which will be converted to Nutri-Score of A because it provides a lot of fiber, protein with no sugars or cholesterol. Whereas a granola bar, which is also made of oats but has a lot of added sugars, will have higher points in Nutri-Score of D or E. Nutri-Score compares the nutritional quality but doesn't indicate the degree of food processing. So Nova grade was then developed to assign foods to four grades according to the extent of industrial food processing. For example, potato, a natural food, will have Nova grade of 1. If it uses oil, a culinary ingredient from Nova grade 2, to make French fries, then French fries will have Nova grade 3. And if the fries are coated with cheese, it will be categorized in group 4. The process of Novus consists of four main processes. First, data pre-processing and explorative data analytics. The dataset used for the food grading pipeline and recommender system originates from Open Food Facts, a nonprofit organization with 1.9 million foodstuffs globally. Its number is down to 190,000 items from the United States with 14 features and targets. For the food grading system, the numerical features whose values outside of quantile 0.99 are considered outliers and are removed. For a recommender system, to increase the number of items in the dataset, the products with missing Nutri and Nova labels are not removed, but they are filled in using the two previously built classification and regression models. Then the remaining categorical features will be pre-processed using regular expression and string manipulation before fitting into the recommender. The Nova target for classification pipeline has a very uneven distribution in the size of each class, with ultra-processed foods, the red color, accounting for 2/3 of the whole data. So an oversampling technique called SMOT was combined in the pipeline to create more samples for the other three minority classes. The regression pipeline for Nutri-Score computes the scores on a scale from -15 to 40 and convert them to the corresponding Nutri-grade labels from A to E. Novus has four models for two main missions, the food quality assessment and the recommender system. The recommender system uses TF-IDF to vectorize the categorical features or ingredients of the product into a vector of numbers to feed into the model. It highlights the important and unique ingredients of the product and ensures that the common and unimportant ingredients such as water, sugar do not dominate. Then cosine similarity will measure how similar the products are and retrieve the top matches to the user preference. For food quality assessment, first is additive detection. The user can input an image of food ingredients that they want to detect. Novus then use PyTesseract, an optical character recognition tool, to extract the text information in the image and pass it through regex to identify any additives based on the enumers and provide the information such as side effects and usage to users. Second is the food grading pipeline, which consists of SMOT for classification tasks, a standard scaler to scale the numerical features, and either a classifier or regression model to predict NOVA and Nutri-Score. After benchmarking several machine learning models, random forest would have the best performance scores and little training time will be fine-tuned to use for a final pipeline. After fine-tuning, the rough AUC score of random forest for NOVA classification is 0.94, and the rough area for each NOVA grade is nearly 1, which is really close to a similar research paper about NOVA grade classification, where the data used for NOVAs is 20 times greater. The feature importance of random forest regression for Nutri-Score shows that saturated fat is the most important feature, whereas the random forest classifier shows that additive tails contributes the most to classify the processing levels of food. This confirms that our two models are working very well because they reinforces the fact that foods with more saturated fat will have lower nutritional value, and the more additives, the more processing level of food. Now is the most important part, Novus MO. Okay. Here, I have an image of a Vietnamese food product. You can see it has some uncommon names that are definitely not food ingredients. For someone who doesn't know about nutrition, it might be difficult for them to distinguish between the ingredients and non-ingredients listed in here. Novus can notify them with the additives as well as the side effects so the user can choose to avoid this product or not. Then, the user can also assess the nutritional quality and processing levels of their food by inserting the nutrition info. This is Oatly, my favorite oatmeal brand. It has 16 grams of carbs, 7 grams of sugar, and 5 grams of fat. So there have been a lot of questions regarding the true quality of this product. Let's see what Novus says. The food nutrition level is C and processing level is 3. That means that Oatly doesn't really bring many health benefits and I should limit consuming it. So how can I find a better substitution for Oatly? If I insert the ingredient oatmeal and hit recommend, Novus suggests that the best substitution it has in store is nut and vanilla milk, which is made from cashew milk with the best nutritional value and lowest processing level, whereas another product, which is made from oatmeal, is recommended as a fourth option because it was more heavily processed. Besides the food quality assessment and recommendation system, Novus also analyzed the packaged food product from Open Food Facts, and Novus found out that non-vegan food in general have very little nutrition compared to vegan foods, since more than half of them have very low Nutri-Grade. In addition, when choosing non-vegan food, 98% of the time you will get a heavily processed food that do more harm than good to you. Non-vegan foods also contain greater amount of bad nutrients such as cholesterol or saturated fat. You can see that these two products from meat and seafood category all have more than the recommended daily intake of saturated fat, which is 13 grams. And in just 100 grams of oyster with garlic and parmesan, you will get 24 grams of saturated fat, which is 2 times greater than the optimal amount of saturated fat per day. And on top of that, almost all packaged foods contain at least some additives. In only one package of dessert, there could be up to 35 additives added for coloring, preservative, or emulsifier. And the most common additive here is lecithin, which is considered safe when consuming at a small amount, but however, a rich a diet rich in processed food and added additives is linked to chronic diseases such as obesity, high blood pressure, and cancer. In the future, Novus wants to automate the inputting process for NOVAs and Nutri grading system and develop an allergen detection using OCR. Secondly, Novus wants to automate the inputting process for NOVAs and Nutri grading system and develop an allergen detection using OCR.
Okay,
We lost the.
I think the internet agrees with the bell. Her internet agrees with our time. So, all right. So, oh, welcome back, sir. Okay,
I'm so
so
sorry. Can I still continue?
I'll give you 30 seconds to wrap it up. Can you do it?
Thank you very much.
Um,
Um, so in the future, Novus wants to automate the inputting process for NOVA and Nutri-grading system and develop an allergen detection using OCR. Secondly, Novus wants to help with the automatic Vietnamese food grading and also providing more nutrition information to Vietnamese people. Lastly, Novus will try to improve the model performance and accuracy for better food quality assessment. And thank you for everyone to listening, and thank you Coder School. Thank you my wonderful instructor and Young and Wang and Jin, chị Ái, chị Giang, my TAs, Min, Nathan, Ngọc, and all my machine learning 30 friends. Thank you so much. Thank you everyone. And that's the end of my presentation tonight. Thank you very much.
wow. Okay. Thank you so much, Joe. Thank you so much. It was my honor to share knowledge with you and work with you throughout the course. So, on behalf of the team, thank you so much for being a very good student. Right.
Thank you.
How about judges? What do you think about this amazing project on nutrition?
Sure. I would love to give my couple thought on the presentation. I love her voice. I love the presentation. The color looks so cute in pink, and everything really well organized, well structured, and the idea is great for somebody that have no like specialized knowledge in food or chemicals, have no ideas what in it and what it may harm my health. Just question whether your project can work well on cosmetic products.
Well, initially, when brainstorming the ideas for this project, I wanted to work on cosmetics, but then I switched to food because I think that cosmetics is only for women, but food, everyone needs to eat. So I think food is more important. And in the future, I definitely will work on the cosmetic products.
Okay, sure. That's it from my side. Thank you. Good job.
Thank you very much.
All right. Yeah. Awesome. So yeah, it's very awesome. So my question is why machine learning was needed for this project? I'm kind of curious, because would definitely is a bad adaptive yield a way more accurate result. Don't you think? Yeah. So is that my curious about why do we have to apply machine learning for this?
Okay. Thank you for your question. First of all, I follow a research paper on NOVA classification that uses random forest, and I was very interested in applying machine learning to automate the process of food grading because most of the food products in Vietnam do not have any nutritional value grade or NOVA grade for processing levels. So if we use machine learning, we can help the process to implement faster and help people with no knowledge about nutrition can evaluate their products. And that's the point of machine learning. And also, with for someone who doesn't know about additives, machine learning can help them detect the additives and just notify them if the product has any additives and the side effects.
Yeah, I see.